After a scientist has planned an investigation, he or she now needs to actually implement the plan. They need to conduct the investigation. They need to do the investigation. And while they do the investigation, they take measurements. In other words, they collect data. And while they collect this data, of course, they need to record it somewhere. They need to represent the data. Data means information which you get from measurement. Data might be quantitative or qualitative. In quantitative data, the measurements are numeric. In qualitative data, the measurements are descriptions. The term samples per treatment means repetitions of the same treatment. So you know that in any investigation there have to be at least 2 treatments that differ in the independent variable. But to make the data more accurate, in each treatment, there should be a few repetitions of that treatment. There should be a few samples per treatment. Repetitions means doing the same thing over again. When you draw a graph, you must make sure you use a uniform scale. A uniform scale has equally spaced increases. So for example, every centimeter might stand for 5 kilograms. You can't have 1 centimeter standing for 5 kilograms and then the next standing for 15 and the next for 7. That would not be uniform. In a graph, the horizontal axis, the axis which goes this way, is called the x-axis. And the vertical axis, which goes straight up and down, is the y-axis. Initial means starting. Final means ending. You find the average of a group of numbers by adding all the numbers together and then dividing by the number of numbers. So for example, the average of 5 and 6 is 5 plus 6, 11, divided by 2 because they're 2 numbers, 5 and 6, and that's equal to 5.5. A raw data table is a table in which you put every single measurement and calculation of your investigation. A process data table is a summary made from your raw data table where you only give the averages of the many samples per treatment and not every single reading. And in a process data table, preferably there are only 2 columns. One for the independent variable and one for the dependent variable. A trend line is a line of best fit in a graph, and you should make sure that it's smooth. So let's say here we have a very rough graph with some measurements shown there. When you draw a trend line for this graph, you mustn't go dot to dot to dot, because nature tends to be smooth in its relationships. And so we need to draw the trend line smoothly to predict what nature is really like. So in some cases, we don't actually go through a dot. We might go between dots. The trend line predicts the relationship between the variables if there were no experimental error. There will, of course, always be experimental error. That's why you can't go dot to dot, because then you are claiming that that variation from the smooth trend line is real, not just an accident of the experimental error.